2, 1.
Hello, this is Ms. Goodale, doing a short lesson on equivalent fractions. I would like to go over this because equivalent fractions can come in pretty handy in a number of ways. It can come in handy when you are adding or subtracting fractions, simplifying fractions, or when you want to compare and order fractions. With that said, let's do an example. If we start with the simple fraction 1/2, all I have to do to come up with an equivalent fraction is either multiply or divide both the numerator and the denominator by the same thing. Since this is in simplest form, we're going to use multiplication. We can multiply by any number. I'm going to choose the number 3, and if I multiply the bottom number or the denominator by something, I also multiply the top by the same thing every time. Whatever I do to the top number, I do to the bottom number and vice versa. So I would do 2 times 3, which is 6, and 1 times 3, which is 3. I can also do multiplication by a different number. Let's say I want to go times 5. 1 times 5 is 5. 2 times 5 is 10. So it's also equal to 5/10. Another example with division is if I had 4, 6. If I look at both of those numbers, they are both evenly divisible by 2. So I would be able to divide 4 and 6 both by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So I would get 2/3, and that is actually simplest form or lowest terms. Another example, let's start with 24 and 40. If I start with that one, I can divide both numbers by 8. And notice sometimes I write this with the division beside each number. Sometimes I just write one division symbol. That's just how I write it. 24 divided by 8 is 3. 40 divided by 8 is 5. So that is equal to 3/5 if you reduce all the way. I could also do the same number, and let me write it onto the left side so that I have plenty of room. So 24 over 40. If I just decided to divide by 2, I could still come up with an equivalent fraction. 24 divided by 2 is 12. 40 divided by 2 is 20. If I want to put it in simplest form, then I could keep dividing. So I could divide both of them by 2. 6 divided by 2 is, or 12 divided by 2 is 6. 20 divided by 2 is 10. And I could divide by 2 again. 6 divided by 2 is 3. 10 divided by 2 is 5. So again, I would get the same answer regardless of whether I divided by the least common multiple, which is the biggest number that goes into both, or if I just divided and divided and divided until I could no longer divide. I would still come up with the same answer. That's a quick set of examples on finding equivalent fractions. I hope you got something out of it, and if you need more help, please feel free to ask.